Hey, this is Mr. Weisfeld. We're talking about quiz number 26, problem number 31, page 631. This maybe looks like kind of a strange circuit diagram. You might not have seen these before like this, so let me just explain a little bit why they draw it like that. So normally we would be drawing them like this, with a battery over here. Well, not like that actually. That's the way this one is. Normally we draw it like this. So a battery over here a resistor, and then a continuous wire down there. Make sure you draw the wider one up top. That's the plus side. This is the minus side. And then we say that there's a potential, an electric potential across the battery, that it's like that escalator from the videos we've been watching. It's raising the potential energy of the charges. Well, the point is, just like how you can measure potential energy, so gravitational potential energy from any level, you can also measure electric potential from any level. And so what the real sticklers do is they say you have to define one end of your circuit to be this symbol here, like a little kind of triangle of dashes, or pyramid of dashes. And what this means is this is ground. And ground is a great name for it because for houses, it's just a stake of metal driven into the ground. And what it means is that this is zero electric potential always. In other words, you can't really create a voltage in the earth. No matter how hard you pull, you might get a local change of voltage, but it's never going to be possible to pull a real potential, electric potential, in the earth or in dirt. So this is ground. That means that the voltage of point C, since it is connected by a wire to ground, is 0 volts. So what is the voltage of point C with respect to the ground? The ground is those this little symbol here means ground, so that's 0 volts, 0 V. The voltage of point D, now since we go up the voltage escalator of a battery, we now have 10 volts. So on the other side of the battery we have 10 volts. Then what is the voltage of point A with respect to the ground? So if there's no resistance in this wire right here, then there is a consistent voltage from D to point A. So the voltage at D is the same as the voltage at A, so 10 volts. Then, what is the value of the voltage across the resistor? So across the resistor, you would have to say that that voltage is also going to be 10 volts. But it's a minus 10 volts because you're stepping down across a resistor. And then you see why you can get back to 0 here, because we're going to put as much current in the resistor as we can to basically get to 0 volts at point B and point C. So now, which point A or B is at higher potential? So I think we can see that yeah, let's see. I guess what if anything is across the resistor? Oh, across the resistor is negative, so down step. E, which point A or B is at higher potential? So A is at higher potential. You have more potential energy at A. And then B takes the potential energy out of the electrical charges. The expression, the magic expression that relates R and V is Ohm's law. So Ohm's law says that the voltage across a resistor is the current times the resistance. And so that's relating R and V. And so when we want to know the resistance of point R, so let's see, F was V equals I times R. And then G is basically the value of the resistance. So if I know the voltage and know the current, then V over I equals R. I should say that there's a cool little again, mnemonic device for remembering how V and I and R combine, and it's the same as like F equals MA. So any of these relationships, you can basically say voltage equals current times resistance. So if V over I equals R, then the value for the resistance is 10 volts divided by 2 amps equals 5. Units for resistance is ohms. So that's a really simple circuit diagram and a really simple analysis, but I just want to make sure that you get used to maybe this symbol here if you see it again, and you also get used to the fact that voltage can come up and then gets dispersed again so that the ground comes back to 0.